Clain Jones has worked in the area of nutrient management at Montana State University since '99 and has been the extension soil fertility specialist since 2004. His research is focused on nutrient management in organic and conventional systems, and currently is studying urea volatilization, nitrate leaching, and the effects of mixed cover crops on soil quality. His extension work has involved developing traditional and innovative methods to deliver nutrient management information, such as web-based interactive optimum nitrogen rate calculator. Recent publications have focused on methods to decrease urea volatilization and increase wheat grain protein. So let's welcome Clain.
Which I'm going to discuss today is on mixed cover crops. And so Perry Miller and I and a few others at Montana State have been studying single species cover crops for about 10 years. So we focused on primarily crops such as peas, lentils, buckwheat, mustard, and then compared following crops yield and quality to subsequent crops yield and quality following fallow.
It's coming. I pulled the plug.
So while that comes up, I just wanted to briefly talk about our strategy for our study. All right, thank you. I have this. So the people who are also working on this project with me are Susan Tallman, who's a Master's of Science student, Kathy Zabinski, who is a soil ecologist, studies mycorrhizae primarily, and Perry Miller, who's the principal investigator and is a cropping system specialist. So the question that Jeff asked before, that I think a lot of you know, why grow cover crops, things like reducing erosion, reducing nitrate leaching, increasing soil organic matter, increasing soil quality, and question is, do we increase soil quality, and do we increase subsequent yield and quality? So some important issues surrounding cover crops. These are ones that we've discovered doing research and also in discussions with growers. One would be, well, what do I plant? Second would be, what timing, when should I plant my cover crop? How should I plant it? What seeding rate should I use? A third question is, how do I manage weeds in my cover crop when a lot of times there's both broadleaves and there's cereals? When should I terminate and how? What are the effects on the subsequent crop and economics? And what are the soil quality effects? Finally, are there any benefits to using cocktails over single species? So I just want to briefly summarize what we found so far on single species cover crops, because we know a lot more there. We've been doing research longer, and then talk more about our mixed species cover crop study. What we found is that subsequent grain yields and sometimes protein are generally higher when we grow winter pea versus either a spring pea or a spring lentil or a winter lentil. We find that we get better grain yields and protein from spring seeded crops rather than summer seeded crops. We get better yields and protein when we terminate our cover crops earlier, meaning somewhere around first bloom, rather than waiting till those crops go to pod. Between bloom and pod is a huge amount of water use for most of our cover crops. And when we till that cover crop in, we seem to get better responses than when we just spray out that cover crop. We're not exactly sure why, but that's what we found. If you want more information on that last topic, you can see Fertilizer Fact 58, which is in the back of the room. We generally find that cover crop wheat is less economical than fallow wheat. If you get an NRCS payment, that might not be true if you don't get an NRCS payment. We generally find that's true, at least in the short term. And why is that? Probably because that cover crop used some water. So just some really brief conclusions on the cover crops work. Conserving water is the most important strategy, and that's why we generally recommend either early seeding or not letting crops go too long. Benefits to the soil and the next crop are often not observed in 2-year studies, which is what a lot of the work Perry and I have done. We do find in long-term studies, meaning greater than 8 years, that we do see increases in soil nitrogen availability, which helps yield, protein, and economic return. We've also found that net revenue likely increases in the long term, but in our longest term study at the post farm west of Bozeman, growing peas for grain followed by winter wheat is still an economic winner over cover crops followed by wheat. Yeah.
Yeah, and that last system in your peas for grain and then winter wheat, are you seeding the peas into fallow at the beginning of your cycle? And then are you leaving that pea ground fallow or seeding winter wheat right into it?
We have no fallow in that system, so it's pea 1 year, then winter wheat, then pea, then winter wheat. So now a little bit more, which is what Jeff has asked for, which is our current study on mixed cover crops, which started roughly 2 years ago, funded by the USDA Western SARE program. We know that North Dakota and Montana farmers have been trying cocktails. There's anecdotal evidence, and we've seen benefits from mixed cover crops, but we don't know why we've seen them, and so the goal of this study is to get more into that. Plus, a lot of the work has been done in the Dakotas, where they get a little different precip pattern than we get here in Montana. So the question is, can they work here in Montana? This is a map from the NRCS that shows the locations in 2011 of where cover crops were being grown. So as you'd probably expect, a lot of them are on the North Dakota-Montana border. They obviously are being grown. The question is, are they working, and what could we do, or what could growers do to make them work better? Apparently Doug's farm's not on there. So the question is, are there differences between where these systems, these cover crop cocktail systems, work pretty well in the Dakotas, western to central North Dakota, and Montana? Well, one thing to really focus on is precipitation. This is a graph that shows from January to December the monthly precipitation for Bismarck in blue, Great Falls in yellow, and Havre in red. Overall, the patterns don't look that different till you get to the summer months. And so in the summer months Bismarck gets about 3/4 of an inch more per month of precip than Havre does, and about 1/2 inch more precip than Great Falls does. So that's really important, both to the cover crop and to the subsequent crop. So questions we're trying to answer in our cover crop study: first, are the cover crop mixtures more valuable than single species cover crops, meaning more valuable to the soil, more valuable to the bottom line? What mixtures or functional groups have a more positive effect on soil quality? And a functional group would be just like it sounds, meaning some sort of function of that cover crop, either a tap-rooted plant that's designed to break up compacted layers, maybe a fibrous-rooted plant like oat, which produces generally a lot of carbon or a lot of organic matter, or maybe a nitrogen fixer, such as pea or vetch. And then what mixtures have a subsequent, more positive effect on subsequent yield, quality, and profit. So the functional groups that we selected for our study, and a lot of this was based on what was already being done research-wise in North Dakota. Our 4 functional groups were end fixers, fibrous roots, so oats or Italian ryegrass were planted in the first year. The second year, the ryegrass didn't do so well, so we switched it over to oats and millet. The millet didn't do so well, so we pretty much had an oat stand. Our third functional group is tap-rooted plants, so the ones we chose were safflower and the purple top turnip. And then our fourth group were brassica. It's not really a function, but we do know that brassicas have some unique properties, and so we planted radish, and camelina. So those are our 4 functional groups. This is what one of our study designs looked like last year. We have 4 farms going right now, including 2 in the Golden Triangle. This shows our plot study where we have 11 different treatments replicated 4 times in blocks. And again, the focus of the study was a little more on soil quality than on subsequent yield and protein, but we also analyzed yield and protein. So besides cover crop biomass, our biological indicators included microbial biomass, enzyme activity, potentially mineralizable nitrogen, so how much nitrogen can come off the soil, get converted from organic nitrogen or residue over to available nitrogen, and mycorrhizal colonization and infectivity, because we know mycorrhizae is really important for increasing phosphorus availability and micronutrient availability. Physical indicators are wet aggregate stability, so we know aggregates help with water flow and air flow, basically improve the quality of the soil. We also are looking at compaction, soil temperature, and soil water as our physical indicators of soil quality. And our chemical indicators, we're focusing on available nitrogen and available phosphorus. We also have a companion full field study on farmers' fields where they've selected what their cover crop mixture would be, and we've asked them to plant half of a field with a cover crop, leave half fallow, and then we've done sampling on either side, really focused on grain yield and quality more than soil quality in that study. Our cover crop mixtures, we're planting them every other year. That might not be super typical for a conventional or an organic grower, but we want to enhance the chance of seeing a benefit. And so in a typical USDA study, which is 3 years, we're going 2012 cover crop, 2013 spring wheat, and then 2014 we're going to do another cover crop. So our 2 locations last year were Conrad and Amsterdam. Our 2 locations this year are Dutton and Bozeman. Last year we seeded in early April. We sprayed out in mid-June for cover crop insurance, for crop insurance reasons. We didn't get very good biomass, typically on the order of 500 to 1,000 pounds per acre. It was a dry spring, and we had a pretty short growing season going early April to June 15th. So this year we decided to, and we also had some downy brome issues, as I'll show you. This year we decided to seed a little later. That gave us a chance to spray out that downy brome, and we decided, okay, let's not worry about that crop insurance deadline. Let's grow them to about first bloom. That's worked for us in other studies. The following test crop this year was spring wheat at Conrad and Amsterdam, and will be winter wheat. It's already been seeded at Dutton and Bozeman. So we didn't have weed issues at Dutton and Bozeman, so we were able to plant winter wheat and not worry about cheatgrass. So we had some pleasant and unpleasant surprises. The first unpleasant surprise was that Conrad last year, our weed biomass was greater than our crop biomass in all of our treatments with cereals. The treatments that didn't have cereals, we were able to spray the downy brome out, and so those looked pretty good. But yeah, this was pretty disappointing when we went up to sample. The second unpleasant surprise was that glyphosate alone didn't kill our common vetch. So this is a photo after spraying. All the other crops are dead, and the common vetch is continuing to grow. It slowly died, but it took a while.
What rate was that?
Label rate, I actually don't know what it was. We find if we mix glyphosate with another broadleaf, then we can kill common vetch. The other practical findings to date, last year we used both the fertilizer box and the seed box to plant our small seeded crop and our large seeded crop in different rows. We found that didn't work as well as what we did this year, which was mix all of our seeds together and put them into just our all through the box. And we seeded shallow. So we seeded more shallow than we typically would for our large seeds, but it allowed our small seeds to compete more readily. The crops that did quite well for us, radish was up to about Susan's shoulders this year. Radish did very well. Oat, pea, turnip, safflower all did quite well. Millet, ryegrass, camelina, and lentil did not do so well. The mid-May seeding worked a lot better than our early seeding for weed control, as you could imagine. We also had, you know, a wetter spring this year, so that helped a lot too. And you do need a herbicide mix, not just glyphosate, to kill pea and vetch, was our experience. So the biggest pleasant surprise was that it rained in 2013. As you guys know, from about mid-May to mid-June, it rained hard. And so this is an aerial of our Kelly Canyon site, showing very plush cover crops. And this is a photo from Dutton, which also shows a very nice thick cover crop and some good biomass yields this year. So I'll walk you through this figure. On the horizontal axis is the treatment. So we have pea grown by itself, which we're also using as a control, meaning I think of fallow as a control, but we've done so much research on single species pea, we know how it behaves. So if mixed cover crops behave about like peas, we think we know how mixed cover crops will behave into the future. This is a full mix, so it has all 8 of our species. The third, which is largely pink, that's our fibrous rooted crops where almost all the growth was oat. The brassica crop included winter canola this year and radish. Taproots included safflower and turnip, and then the end fixers were this year lentil and pea, since we had trouble terminating our common vetch and it didn't produce a lot of biomass. When we run statistics on these, there's no difference among these 6 different crops. And in fact, we had 4 other mixtures that busied up this slide, but there was no significant difference between crops, although I note that the full did seem to have a higher biomass than the other 5, which makes sense and agrees with other literature that when you plant more species, you generally produce more biomass. The other really large differences that we saw between treatments, I'll show you that we didn't find a lot of differences between treatments biologically, but temperature was a big difference. So we recorded temperature 2 inches down in the soil. This shows from June 10th through August 5th, the temperatures of these different cover crops. The temperature ranging from about 60 degrees to about 90 degrees, and these were all at 4 p.m. in the afternoon. The red squares are fallow, so as you'd expect, the warmest soil was fallow, followed by the fibrous, meaning oat, and then the rest of the cover crops followed. The end fixers and the peas had the 2 coolest temperatures, and that's probably because, again, they were hard to kill. So they probably continued to use water, transpiring, shading a little longer than the other crops did.
Was the fallow cultivated fallow or chem fallow?
Chem fallow. Yeah. So most soils were cooler under the cover crop than under the fallow for over about a month. What benefit do you see to having cooler surface soils as growers?
No evaporation.
Yeah, so maybe a little less evaporation. Anything else you can think of? I thought about things like crusting, really baking that surface, maybe killing some microorganisms right on the surface. So I can see several advantages potentially to cooler temperatures. We also found with potentially mineralizable nitrogen that pea was at both of our sites, we had more potential mineralizable nitrogen than on fallow after pea. So that would make sense, but we also did at one of our sites from our full mix was greater than fallow at one of our sites in Amsterdam, but not at Conrad. They were significantly not different. We found no differences in microbial enzymes, microbial biomass, or penetration resistance last year in the 2012 treatments, and we haven't analyzed them in 2013. Not a huge surprise, you know, we'd only grown them once. We would expect these things to change over time. Subsequent wheat yield the data is being compiled, but it was pretty obvious just holding the bags that wheat following fallow did better than wheat following cheatgrass, basically, at our site at Conrad.
Totally, yes, I think it's true.
We haven't analyzed our wet aggregate stability, our mycorrhizal fungi, or our nitrate data. We haven't collected, we just haven't analyzed it statistically, so do stay tuned on those. And then if you want information from a study where they also have a grazing component, Darren Boss of the Northern Ag Research Center is conducting a larger plot study there where he has different timings of seeding and termination and a grazing component. So it's our study times about 4. So do talk to Darren if you are interested. So in conclusions, our results based on both single species cover crops and mixed species cover crops based on 2-year studies is that they generally do not benefit soil quality, yield, or economics in the short term. But in the long term, and this is based on a study up in Culbertson, Montana, another in Western Canada, and one just west of Bozeman, in the long term, single species cover crops have been found to increase grain yield and protein, especially under low nitrogen conditions. Cover crop cocktails may have benefits over single species, but benefits to soil quality have yet to be documented in Montana. I would hope that we could continue our study with some other funding source because I don't expect to see large differences in just 2 cycles, but after maybe 3 or 4, I would expect to start seeing differences. If you want more information or you want any of my documents electronically, you can go to my website. If you can't read that, you can just Google Clain, C-L-A-I-N, and soil, and my website will come up. We have fact sheets that I've mentioned on there. This presentation will be posted if it hasn't been already, so there's a lot of good resources there for you.